Good day, everyone. I have a question on the board, which is on a topic in mathematics. The topic is called complex number. I'm going to treat complex number as a topic fully on my Facebook page. But this is just an extract of a question from the topic complex number. Now, for a layman, how do we know that this question is particularly from complex number? Let's read through the content. If z plus I all over z plus 2 is purely imaginary, look at that word, imaginary. That word shows that this is a question on complex number, because it's only in a complex number we have the real part and the imaginary part, which is written as a plus ib x plus iy, depending on the letters. Now, these are the real part of the complex numbers, while these are the imaginary part of the complex number because of this I. Let us not forget that I is the sign of imaginary. I stand for imaginary. Okay. Now, if this is purely imaginary, prove that point x, y is the locus of a circle of radius √5/2. Hence, find the center of the circle. Okay. To prove this, since we are given the coordinate x, y, let the complex number z be x plus iy. So that means I'm going to use this to replace z in the given question. So that will now lead me to x plus iy plus I, which is this, all over this z is x plus iy plus 2, which is this. Okay. Having done this, what is the next thing to do? The next thing to do is to collect the like terms of imaginary and real part in the numerator and the denominator. So I'm going to have x plus I open bracket y plus 1, because I is common to here, all over open bracket x plus 2 plus iy, because this x and this 2 do not have anything to do with I, which is imaginary. That means the whole of this bracket contains the real part, while this y is the imaginary part. Now, what next? The next thing now is to ensure that we remove the imaginary part of the what? Of the denominator, which can be done by undergoing a process similar to rationalization in surd. Yes, you know that if we want to remove surd at the denominator level, we will carry out rationalization. So something similar to that rationalization is what we want to do now. And how do we achieve that? We achieve that by introducing the conjugate of this imaginary number at the denominator level. What do I mean by conjugate? Let's go there first. All right. If z equals to x plus iy, we all know already that z is a complex number. Then by z, this bar shows conjugate of z. So we pronounce this one as conjugate of z. That means the conjugate of this z, which is going to be x minus iy. Observation. You will observe that this positive sign with the imaginary number or imaginary part of this complex number has been changed to negative. So whenever the imaginary part of two complex numbers have opposite sign, one positive, one negative, while the numbers, the real and the imaginary numbers remain the same, then we call them conjugate. As you can see, x remains x, y remains y. The only difference is the positive and negative sign, which shows conjugate. Now, that means if I want to find the conjugate of this now, all I need to do is to change this positive sign to negative. So now, why this and this remain the way they are, only this sign will change. Therefore, I'm going to carry out the multiplication of the numerator and the denominator by the conjugate of the denominator. Now, I have multiplied the numerator and the denominator by the conjugate of the denominator. This over this is the original information we have from the question. But now, I want to remove the imaginary part from the what? Denominator through the process similar to rationalization. So I have to multiply the numerator and the denominator by the conjugate of the denominator. As you can see, x plus 2, positive, negative, iy. So this is the conjugate of this. These two complex numbers are conjugate of each other. So whatever I use to multiply them must be used to multiply up. So let's now expand. By expansion, it means x multiplied by x plus 2. That will be x into bracket x plus 2 minus ixy. This x times iy. Then this one to multiply this. That will be plus into bracket y plus 1. Plus I into bracket y plus 1 bracket x plus 2. I am using this to multiply this. Then this times this, plus times minus, that will be minus. Then I squared bracket y plus 1 bracket y. That is, this one multiply this. I times I is I squared. Okay. All over, I'm going to do same here. But there's something I want you to note. Anytime you are multiplying two conjugates together, all you need to do is to square the two parts. That means x plus 2 raised to power 2. Then plus times minus, that is minus. Then you square this, that will be I square y squared. So I have been able to multiply the conjugates. If you carry out the expansion as I did here, you will get the same. But the shorter way of multiplying conjugates together is to square the imaginary and the real part separately with a negative sign in between, and I square coming with the imaginary side, because I times I will be I squared. Now, let's go there. In this case now, I am going to expand further, then collect the like terms that have to do with imaginary and the what and the real part. As you can see, it is very obvious that if I multiply this one now, x That will be x squared plus 2x minus ixy plus ixy plus I2y plus x plus ix plus I2. I've been able to expand all these brackets. Then minus I y squared then minus IY. So that's the expansion of the numerator. All right. Now, having done the expansion of the numerator, which is this, and the expansion of the denominator, which is this, what next? We simplify further. How do we simplify further? Okay. Anywhere you see I squared, it means minus 1. This was introduced by Euler, that I is equal to square root of minus 1. So let's take note of that. So if I is square root of minus 1, that means squaring both sides, I squared will be minus 1. So anywhere we arrive at I squared, it becomes negative 1. So let's take note of that. So having noted that, this will now become x squared plus 2x minus ixy. Okay, minus ixy will cancel plus ixy to save our time. So what do we have? We have I2y plus I2y plus ix plus I2. Then I squared will become minus 1. So minus 1 times minus, that's negative times negative, that will be positive. That is plus y squared. Then I squared here also will become negative. So negative 1 times negative, that will be plus y now. All over x squared plus 4x plus 4 plus y squared, because I squared will become negative 1. Negative 1 times negative, that will be positive y squared. Okay. Do not forget that from the information in the question, we are told that the given question is purely what? Imaginary. So that means I'm going to separate the numerator and the denominator into real part and imaginary part. So what are the real parts? That's x squared plus y squared plus 2x plus y. Then what are the imaginary parts? All those with I. That will be plus I into bracket x plus x plus 2y plus 2 all over x squared plus 4x y squared. Or let me rearrange also. X squared plus y squared plus 4x plus 4. Okay? Now, since the question says it is purely imaginary, therefore, since it is purely imaginary, therefore, real part is equal to 0. For example, if you have x plus iy equals to 0, equals to, let's say, 3iy. So from this, it shows that this x is 0 here. Why this y? Plus 3i3, sorry. Why this y is this 3? So, since it is purely imaginary, that means the real part will be made to be equal to what? 0. That means it doesn't exist. It's equal to what? 0. So what do I do? Sorry, it exists as 0, equals to 0. Okay, that means the real part, which is this now, x squared plus y squared plus 2x plus y all over x squared plus y squared plus 4x plus 4 equals to what? 0. Since the whole question is purely imaginary, that means the real part will be 0. Now, what next from here? From the knowledge of algebraic fraction, as you can see, the whole of this is algebraic fraction. When a fraction is equal to 0, what does that mean? It means only the numerator equals to 0. That's the meaning. But when we say a fraction, excuse me, a fraction is undefined, it means that only the denominator equals to 0. So now that we have the whole fraction being equal to 0, that means under algebraic fraction is only the numerator that is equal to 0. Only numerator equals to 0. And what is the numerator? X squared plus y squared plus 2x plus y equals to 0. This is the equation of the circle. How do we now prove that the radius of this equation of the circle is root 5 over 2? That is the next thing coming up. Now, the information written on the board is just an extract from the topic called circle. The general equation of a circle is this. G represents negative A, F stands for negative B, C equals to A squared plus B squared minus R squared. If you go to one of my video on my YouTube channel, that Science Explained _KA, I have treated equation of a circle there. Now, A, B, this are the coordinates of the center of the circle, and R is the radius of that circle. So I'm going to now compare between this equation I arrived at from working on the complex numbers given and this general equation of the circle, and let's see what is going to come out of it. Now, by comparing coefficients between the coefficient in the equation arrived at and the general equation of the circle, it is obvious that 2x is equals to 2gx here, because 2 is the coefficient of x, 2g is the coefficient of x here. So from there, g is equal to 1. And since g is negative a will be negative g, which is minus 1. So also, 2fy is compared with y. That means 2fy is equal to y cancels y, giving 1 here. f will now be 1 over 2. Since f is negative b, so b will be negative f, which is negative 1 over 2. So we have been able to get the center, the coordinate of the center. Now, we have known that a is negative 1, b is negative half. So the center of the circle is minus 1 comma minus 1 over 2. Now I want to get the radius. From the excuse me, from the start, I wrote that c equals to a squared plus b squared minus r squared. That is from the general equation of a circle. And if you look at this equation we arrive at, after working through the complex numbers given, you see that there is no any constant on the left side. So that means since there is no constant and c is a constant here, that means c is equal to 0 from here because there is no any number here. Supposing that we have, let's assume that we have like maybe minus 3 here now. That means c will be equal to minus 3. But since there is nothing, if you go back to the equation we arrive at, that means c is equal to what? 0. Therefore, 0 is equal to a squared, which is minus 1 squared, plus. So 0 has replaced c, minus 1 squared plus minus half squared minus r squared. By transferring r minus r squared to this side, it becomes positive r squared, which is equal to minus 1 squared is positive 1, minus half squared will be 1 over what? 1 over 4. So when you add this to this, you get r squared equals to 5 over 4. And you square root both sides. That means you are going to get r is equal to plus or minus root 5 over 4, which is equal to plus or minus root 5 over 2, because square root of 4 is 2. So we have been able to prove that radius of the circle is what? Root 5 over 2. While the center we are asked to find also is negative 1 comma negative half. Thank you. So if you like this, do not hesitate to subscribe to my channel, like it, and share. I have promised that I'm going to treat this topic, complex number, as a topic fully on my Facebook page. The day of the event and the date will be communicated later. Thank you for watching.